So we have a problem here. The top and bottom margins of a poster are 6 centimeters, and the side margins are 4 centimeters. The area of printed material on the poster is fixed at 384 centimeters squared. Find the dimensions of the poster with the smallest area. So we're going to need a really good picture. So I have a poster with some outside dimensions, and inside I have a printed area, which I'm going to call X by Y. And I know that's fixed at 384 centimeters squared. I also know that I got told the margins on the side were 6 centimeters both these ways, which I'm going to leave the units off. It's all centimeters, and 4 centimeters these ways. So I know my outside dimensions are X plus 8, and I know my outside dimension here is Y plus 12. So I know now that what it says to do is it's fixed X, Y at 384. Maybe you're paying for ink, and they want to get the smallest piece of paper. All right? So we want to optimize the outside area. I want to optimize area of the poster, which is X plus 8 times Y plus 12. But again, you get to this equation, you should say, I want to optimize A, but I have to have one variable on the right, I have two. So I need to pitch a variable. I'm going to solve this for Y. You could have solved for X, I just picked it. I have no particular reason for picking that. And I get 384 over X plus 12. And now I want to take the derivative of this function. Now, I'm looking at A, because I want to optimize and find the local min. I think it's going to be easiest to go ahead and multiply these two binomials together. So I'm going to get A equals 384, X times 12 is 12X, 8 times 384, I suppose I should get my calculator out, but some good practice. 3,072, and I'm going to bring X up, X negative 1 plus 96. Now, I suppose I could combine like terms, but I really don't care. So I'm just going to take the derivative of A, because I know the derivative of 384 and 896 are going to be 0. So A prime is going to be 12 minus 372X to the negative 2. And I want to optimize, so I'm going to set A prime equal to 0. Now, I'm going to have to get a calculator. And when I get my calculator here, I got some math to do. And sometimes I see it better if I do it this way. I'll move this to the other side. Multiply by X squared. So 3072 divided by 12 equals X squared. 256 equals X squared. Take the square root, and I get plus or minus 16. I ignore the minus because obviously a length of a piece of paper has to be a positive domain. And I have just found X. And I would have that be the area of the printed paper. The original question here at this point says find the dimensions of the poster with the smallest area. Well, if X is 16, I get an area here, 16 plus that is 24. I use the green equation. There's no reason to really overthink this. Take 384 divided by 16, and I get Y is 24. So I get that the length here is 36. So the smallest paper is 24 centimeters by 36 centimeters. And we have optimized the poster side with a fixed print area. Again, these problems take practice. The hardest part is setting up these initial equations up here. Keep practicing, it gets easier.